the missing side of a right triangle using the Pythagorean theorem. It's important to review this concept for when we have to find distance in the coordinate plane. Okay? Even if you're like, OMG, I know how to do Pythagorean theorem, make sure you're paying attention, because the more fine-tuned you have it, the easier it is. What is the Pythagorean theorem? Do you remember what that is? Yeah, a squared plus b squared equals c squared. Where if you look at this diagram in the box, A and B are representing your legs of the right triangle. In other words, the sides that are making the right angle are your legs. The hypotenuse is always your C. And the hypotenuse is the side that's across from the right angle. Right? The legs are the sides next to the right angle. The hypotenuse is the one that's across from the right angle. Does it matter which one's your A and which one's your B when you fill in the formula? No. Any leg, it doesn't matter. What matters is your hypotenuse is always your C. And the hypotenuse is also, remember, which side of the triangle? The longest. Right? That's also important. Hypotenuse is the longest side of a right triangle. The legs are the two shorter sides. Doesn't matter which one you make your A or your B. Your hypotenuse has to be your C. Okay, so let's practice some of these. We want to find the missing side of the right triangles, and we're going to round to the nearest tenth. We maybe simplified the previous math class, and we just wouldn't round. You don't mind if you round on the OST, so I don't mind if you round in here. Okay, so I like to label my C first. I label my hypotenuse. I start at my right angle, and I go across from it. That is my C. I label that first. And then my other two sides are my A or my B, but it doesn't matter which one you make A and B. I'm just going to do that. You could have made 10B and 24A. That does not matter. But your C has to be X. Right? And then we just plug those values into the Pythagorean theorem. We don't know what A squared is. Oh, you know what it is. Sorry. A is 10 squared. B would be 24, so 24 squared. And C is representing X. We don't know what that is. I don't mind if you just plug this all in your calculator in one step, or if you need to break it down into 2 steps. I don't care. What do we get when we do 10 squared plus 24 squared? 576. So we do 10 squared plus 24 squared is 576 equals x squared. Then what do we need to do on both sides? X isn't by itself. We have this square. How do we get rid of that square? Yeah, you make it radical. You square root. So x is equal to, what's the square root of 576? Have a fun game after notes. Fast reading. 676. Sounds more like it. 676. What do we get when we take the square root of 676? So the length of that side is 26. Yes. Questions over that? Here, again, label my C first. I go to my right angle and I go across. That is my C. X is not always your C. Don't forget that. That happens sometimes. Sometimes you just go, whatever my X is, that's my C. No. The one that's the side across from your right angle. That's always your C. Okay. And then make that my A, make that my B. Again, your legs don't matter, but side 24 has to be your C. Plug it into the Pythagorean theorem. My A is x, so x squared. My B is 6, so 6 squared. And my C is 24, so 24 squared. And then we're just solving for that missing side, solving for x. Alright, so let's clean it up. Let's get rid of those squares. That's just going to stay x squared. Can't really do anything with that. What's 6 squared? 36. What's 24 squared? 500 what? 76. To get x by itself, what do I have to do with that 36? Subtract it. So x squared is equal to, what's 576 minus 36? 540? And then what do I need to do on both sides? Square root. Is 540 a perfect square? We get a whole number when we square it. Now, I'll show you here. So in Desmos, you just do, so your little keyboard, just do the square root of 540, and it gives you 23.2379 and a bunch of other numbers. The directions said, and unfreeze it, the directions say, when you take the square root of it, round to the nearest 10. How many decimal places is the nearest 10? 1. So you go to the decimal point, nearest 10th would be the first decimal place. To round, go to the next number. What does that 3 do to the 2? Keeps it the same. So our answer would be 23.2. Sometimes it asks for the nearest 10th, which is 1 decimal place. Sometimes it asks for the nearest 100th, which is how many decimal places? 2. Those are the big ones that you're asking here. 10th and 100th. 10th is 1, 100th is 2. And 10 has 1 0, 100 has 2 zeros. Remember your placement. And this one, again, we're finding our x, so go to your 90, go across, that's my C. I'll make that my A and that one my B. Fill it in the Pythagorean theorem. My A is 24. My B is x. My C is 26. And then we clean it up and solve for x. What is 24 squared? 576. 24 is like our favorite number. 576. Just like the other one. What's 26 squared? 676. Then get x by itself. Move that 576 over. What's 676 minus 576? 600. To get x by itself, what do we have to remember to do? Square root. And what's the square root of 100? So our answer is 10. It's the biggest thing. This isn't, Pythagorean theorem, we've done it a bunch. I think we feel pretty confident about it. The biggest thing that I see is we forget that last step of square root. Have to remember square root. X is not by itself until you get rid of that square. Questions over that? Nice little review, right? Well, what's really nice about the Pythagorean theorem is we can use it to find distance of a segment. Okay? Distance in between 2 points. So all what you have to do is you're either going to be given an already drawn segment or you're going to be given points to plot. So if your segment's not already drawn for you, plot the points, and then what you're going to do is sketch a right triangle. Okay? You're going to label your A, your B, and your C. The length of the segment that you're trying to find is always going to be your C. Plug those values into the Pythagorean theorem, solve for C, and your answer is the length of that segment. Okay? The reason why we can do this is because when we use Pythagorean theorem, we're trying to find the missing side, the length of a right triangle. So when we're finding distance, so this line in example 1, we want to find the length of AB. Well, if we just draw a right triangle, I'm going to go down. My board is not the most oriented board in the world, so bear with me. But if we just draw a right triangle, so I'll start at B and I draw a line down till I'm in line with A. Then go to A and draw across so I intersect that other line. Okay? We can easily find the distance of the legs because they're nice and flat, right? We can't really know what the distance of AB is because it's slanted. We can't count to find the distance of a slanted line. We can count to find the distance of straight lines. Okay? So when I count, here, the length of this side is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the length of that side is 9. When I count on the bottom, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we know this side is 9, that side is 12, and we're trying to find AB. Well, we have a right triangle. We find the missing side of a right triangle by using the Pythagorean theorem. Okay? Here's technically my right angle right there, so the side across from it is always my C, and it's always going to be the segment you're trying to find. Then it doesn't matter. I'll make this my A and that my B. Plug it into the Pythagorean theorem. We said our A was 12, our B was 9, and the C is what we're trying to find. And whatever C is going to be our final answer. So what is 12 squared? Math. 144. What's 9 squared? 81. What's 144 plus 81? You can also do this in one step with your calculator or decimal calculator. 225. Are we done? What do we still have left to do? Square root. So we take the square root. What's the square root of 225? So the length of this side is 15 units. 15 boxes. You just can't get that from counting. Square. We can count when it's a perfectly flat line. Any slant to it can't count. You have to use Pythagorean here. Okay. Questions over that? Sometimes with these next two examples, the points are not already plotted for you. Funny enough, the hardest thing about this is making sure you plot your points correctly. Double check the counting. Because you might accidentally, I know these grids, you're asking a little cross-eyed, it happens to me, plot the point wrong on accident. You know how to plot a point, you just accidentally plot it wrong. So then you get the wrong answer. That's the biggest thing. So one thing that will help, I think, what you can do is when the points are not plotted for you, you can go to Desmos and plot them. Okay? You just have to make sure your screen is on 10.5. This is what it automatically should pop on your test when you take the OST. But it's always going to be, make sure it's on 10.5. 10 and 5 are on your grid and that's it. These minor lines are counting as by ones. But just plot the points. Plot negative 3, 1. You have to put the parentheses. Negative 3, comma, 1. Close the parentheses. You can even label it if you want to. Alright? And then plot the other point, 5, 7. And Desmos plots them for you. So as long as you're typing them incorrectly, you don't have to worry about making that little error. And then, what you are allowed to do on your OST, and what we're going to do in here, is we have nice thin markers. You can draw on your computer screen with an expo marker. I understand if you have a personal computer not wanting to do that for the school Chromebooks, you're fine with it. You can draw, take an expo marker, and just draw, connecting your points, and do all your work on Desmos. Okay, you can make your right, use your Sharpie marker, and I'll let you use it. But use your Sharpie, make your right triangle, and do all your work on Desmos. That's fine. That takes away that error of accidentally plotting points. Double check that you typed them correctly. Okay. Little plot. But on the grid paper, we'll plot it here, just so you have it in your notes. So you can reference it in your notes. And connect. Okay? Draw your right triangle. Count your sides. What's the length of this up and down side when we count? 6. What's the length of the bottom side when we count? And then this side across here, the side you're trying to find is always your C. So always across from your 90-degree angle. Make this my A, make that my B, plug it into your Pythagorean theorem. We said A was 8, B was 6. Solve for C. What's 8 squared plus 6 squared? What's 8 squared plus 6 squared? Come on, then. Are we done? No. What do we have left to do? Square root. Don't. That's the biggest thing I see. We do a wonderful job. We forget this last step. This point. What's the square root of 100? Questions over that? Okay, one more. Again, plot those points. Plot them on grid paper. If you just like working on paper, plot on grid paper. You can always try decimals too. Plot in decimals. Use your Excel marker. You can do that when we do the practice next week. We can work with that more. Or what we're doing in the practice today. We have -2, 5. We're going to plot that point. And we have 8, 0. I'm going to plot that point. Connect your line. Again, the biggest thing is we accidentally plot a point wrong. Maybe you need to double check what you're plotting in decimals to make sure it looks the same. Make your right triangle. And count. What's the length of this up and down side? What's the length of the count across of the bottom side? And then the side across of your right angle, the side you're trying to find is always your C. The segment's always your C. Again, plug in your Pythagorean theorem. Okay. And I'll make the bottom A and the side B. Doesn't matter. Okay. So I have 10 squared plus 5 squared equals C squared. What is 10 squared plus 5 squared? What do we still have left to do? Square root. Don't forget the square root. And what's the square root of 125? 11.2. Round to the nearest 10. Questions over that? Not bad. Okay. This is really helpful for what we're doing next week. This is kind of the basics of just finding distance of a line, and then next week we'll talk about finding distance of multiple lines in one problem. Okay.